Hello there and welcome to A2 Maths from Specimen Paper 2, and here we're looking at question 13, an awesome trigonometry question. So show that cosec 2x is plus cot 2x is equal to cot x. So left hand side, that's going to be identical to, it doesn't really matter if you use the triple equal to brackets or the double equal to brackets. All it means is that for any value of x, this equation or this identity is correct. So what I'd suggest we start off with is writing this out as sine and cos. So it's going to be 1 over sine 2x plus cos 2x over sine 2x. Great, so immediately we've got 2 sine x cos x is on the bottom. So let's expand out the brackets now, expand out the double angle formulas. So it's going to be 1 over 2 sine x cos x, and then it's going to be plus, well, I'm not sure what I'm going to turn this into yet, so I'll just write this as cos squared minus sine squared x over 2 sine x cos x. Okay, so let's now put this together because they've both got the same denominators. 1 plus cos squared x minus sine squared x. I can see what's going to happen here now. Over 2 sine x cos x. Now, sorting out this numerator here, 1 minus sine squared, that's cos squared. So I'm going to get another cos squared on the top. So effectively I now have 2 cos squareds on the numerator, and I have 2 sine x cos x on the denominator here. So cancel out the 2's from top and bottom, cancel out one of the cos's from the top and the bottom, and you're left with cos x over sine x, which is identical to cot x, which is identical to the right hand side of what we're trying to prove here. Great, so awesome proof there. So we first of all wrote out cosec and cot in terms of sine and cos, expanded our double angle formulas, and then the trick here was to spot that 1 take away sine squared was cos squared. Now I've got 2 cos squareds on the numerator there, and cancel out the 2, cancel out the cos, and you're back to cot x. Great, so what we can now do in part B is use our expression for cosec 2x equals this and cot 2x equals this to give us cot of this expression here. So if I want to solve this thing equals root 3, then what I can do is I can set, well, 2x will equal 4 theta plus 10. So therefore x on its own is going to equal 2 theta plus 5 degrees. So therefore now x is 2 theta plus 5 degrees, so the equation that I'm now going to solve is cot 2 theta plus 5 is equal to root 3. Okay, so how have I got that? Well, I've noticed that inside my cosec and cot, I have 2x, and that should match up with 4 theta plus 10, so therefore x must match up with 2 theta plus 5, and I've just proved that when I combine cosec and cot together like this, I can actually simplify it just down to cot of a single x equals to root 3, so therefore it's just cot of a single x, which is 2 theta plus 5, equals root 3. Now what I need to do next is I now need to turn it into a tan, so 1 over tan 2 theta plus 5 equals root 3. So therefore, just manipulating this, multiplying the tan 2 theta plus 5 up to the top, dividing by root 3, I get tan of 2 theta plus 5 equals 1 over root 3. Now, I need to make sure that my domain is sorted. My domain should be in between a theta value of 0 to 180. So when that gets enlarged up to a 2 theta value, it now is in between 0 to 360, but then when the 5 gets added in as well, I'm looking for solutions in between 5 degrees and 365 degrees now. So, now doing tan inverse in degrees mode, I'm going to get 30 degrees. 30 degrees, or add another 180, I'm going to get 210 degrees, or add another 180, I get 390 degrees, which has gone too far. So these are my two potential solutions. I now need to take away 5 from them, so it's now going to be 25 and 205, and now I'm going to divide by 2, so it's either going to be 12.5 or 102.5. There we are. So that's the answer for theta then, 12.5 and 102.5. That's the answer to question 13. 5 marks for both of those parts, 10 marks in total. Let's now move on to the final question of the paper, question 14.